Hi, I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer E Club's Ask the Cook. Since I bring you Ask the Cook from the kitchen, I'm thinking about thermal properties. How do you know the polymer that you've selected will survive the temperature environments in which it will find itself? I want you to think in terms of two cases. I want you to think in terms of a use case. Those are the temperatures it's normally expected to see when used. And an abuse case. Those are the cases that may not be that common, but it is possible that it will see that under conditions that cannot be considered abnormal. And remember those values. We can use those later as the design value. What loads will the polymer experience at temperature? It's very important that you know the temperatures and the loads in order to select the polymer for the task. Now, what do you need to know? You need to know if your polymer is amorphous or semi-crystalline. Polymers cannot fully crystallize from the melt because of molecular weight limitations, to their mass transfer. But I don't want to call these things crystalline. I want to call them semi-crystalline for that reason, if they contain any crystallinity at all. The amorphous polymers, the value you need is Tg, the glass transition temperature. This is a very broad range of melting phenomena. The Tg is in the middle of that range. And for these things, your abuse case needs to be completely outside that range. So you may want to do 20 to 25 degrees C more than your abuse case temperature for the Tg, the material you select. Now, for the semi-crystallines, their melting point is called Tm, and that's a very narrow range. So all you really need to do with those is make sure that your abuse case is below the Tm in order to avoid thermal problems. Always remember to check very carefully the loads and device failure modes, and do thorough testing whenever you work with polymers. Now, knowing that Tg is the bounding temperature for amorphous polymers performance, and Tm is the same for semi-crystalline, that's working knowledge. That's what you get when you watch us here, Polymer E Club, Ask the Cook. Don't forget to subscribe, like, and share if you appreciate the content. You can follow a link in the description to learn more about the Polymer E Club and how to get involved. I'm Todd Cook for Polymer E Club Ask the Cook. Thanks for watching.